Really appreciate you being here. My name is Mike Colino. I'm the Chief Architect of our Modern Applications practice at AHEAD. And this morning's session that I'll be walking you through is how we coach our enterprise customers to establish a framework for building modern applications. Aside from some of the key points that Dave made this morning, one might wonder, why do we need a modern application framework, and why is application modernization so important to our customers? In many cases, this story starts with the problems and impediments organizations face today in terms of moving faster. And so it's important to understand some of the symptoms and ultimately some of the problems that we're trying to solve for. The first problem is incremental monolithic application design and architecture. In many cases, organizations today are dealing with core systems and core applications that have been slowly built up over the course of the last 5, 10, 15, 20 years. And that complexity, as well as their monolithic architecture of having to redeploy the entire application anytime a system change is made, ultimately creates a great amount of complexity for our customers. Second, and tied to the architecture problem inside of incremental monolithic design, is the fact that every single time we need to redeploy our application, in many cases we need to go out and completely and manually regression test our applications. Aside from the pain in doing that, we also have, in many cases, a very arduous deployment process that has not been simplified or matched and married to a DevOps model. Speaking of DevOps, that siloed collaboration, things that I've seen 15, 20 years ago, not only in industry, but also still in practice today, is ultimately slowing our teams down and throttling the capability and throughput that they can provide in terms of business value out to their partners and ultimately their customers. And then lastly, we see a lot of organizations today still struggling with, wrestling, and ultimately feeling the burden of managing enterprise infrastructure. And when we take these 4 challenges together, again, organizations, many of them walk in the door facing many of these, one or more of these. We have this opportunity to go out and create not only a new vision and a new process, but ultimately allow them, through the use of a framework, to be able to conquer these challenges and ultimately help them move faster. But first things first, one of the things that organizations tend to ask us is, this seems like a very daunting challenge, and in many cases feels like a daunting task. How and where can we start? And I think rather than looking at the individual applications to start modernizing, there's a greenfield opportunity here to really just stop the practices of previous decades. And so when presented a greenfield opportunity, not only is that a great place to start, but it's also a great place to stop. It's a great place to stop in terms of the digging that we've been sort of building and subsequently we've been challenging ourselves with in the past. We want to stop the digging process. We want to start and pivot towards a new future. And so I love this quote from Sir Dennis Healy, who says, "The first law of holes is if you find yourself inside of a hole, stop digging." And that's very, very true for our customers and our recommendations to those customers. So let's talk about a framework for building modern applications. And we're going to try to simplify this as much as possible. There are some intricate aspects of sort of the challenges that ultimately will be presented and ultimately some delicate choices that need to be made along the way, some easier than others. But in combination, this framework should allow you and your organization to more seamlessly identify applications that need to be modernized, as well as more aggressively approach going about and transforming those applications. So we'll break down these in detail, but it's a simple 3-step list. First is finding the cloud native balance. Again, this is all about the trade-offs that you're going to need to make as you look at modernizing applications. We'll dig into that in a little bit more detail. Second would be embracing an event-driven approach. We'll talk about, again, one of the ways in which we can sort of start to slide the scale away from monolithic design is move towards event-driven systems, especially when we're building distributed applications. And then lastly, the third piece and component of this framework, test test, and test. Again, we're not going to be able to rid ourselves of the arduous regression testing processes that are in place today without building an automated suite of tests that allow us the confidence to be able to make changes more rapidly in the future. And we'll dive into what that means. Okay, one of the things that I want to do kind of up front is really just highlight how the digital world has sort of evolved over the course of the last 10, 15 years, and how we got to the point where we're at today, where application modernization is not only so important, but in many cases, it's absolutely critical and necessary for survival. If we look at sort of 2007, 2008, the inception of the iPhone, 2008, the App Store coming online, we see this dramatic sort of change in our history as it relates to technology, especially within enterprise computing. And so we look back 15 years later now, and we identify some of the things that were going on at that particular point in time, as well as some of the decisions that we made that are ultimately becoming a driving force for us to change and iterate moving forward. In 2008, when the App Store came online, there was an impetus for enterprises to go out and plant a sort of a corporate branded flag in the App Store. And in doing so, because application architectures at the time weren't enabled to be able to serve up digital experiences, there were a lot of chewing gum and popsicle stick solutions that were put in place. We needed mobile and purpose-built REST APIs, but that didn't necessarily fit with what we had, which were monolithic, sort of vertical scalable applications only. We had, sort of looking back now, we've essentially gone out and created a bunch of point-to-point integrations across our organization in order to satisfy the needs of digital. And we still have a lot of traditional, what I would call data integrations, where ultimately data inside of an enterprise isn't made available in real time, and in some cases is traveling through and being executed by some more traditional batch integrations. And so looking back 10 years later, we understand that we had a job to do in terms of the enterprise in again, planting a flag in the App Store, making our web applications responsive. But in looking back, we understand that we've done a lot of things very quickly, very hastily, and now is an opportunity for us to not only sort of recharge, but redraw the strategy as it relates to being able to handle digital in the future. So if we contrast this to what we call the sort of second wave of digital, we see digital sort of becoming a first-class citizen inside of the considerations of enterprise IT. We see other ambitions that we've talked about for the last 5 to 10 years, such as IoT, becoming a formidable aspect and idea inside of large organizations. And we see a movement away from some of these point-to-point integrations to traditional data integrations, primarily on the batch side, and moving towards streamed-based architectures. And so not only that, but we also are moving away as part of this app modernization effort away from monolithic applications to more distributed systems, ones that we can horizontally scale much more easy. Okay, so let's dive right in. Let's talk about finding the cloud-native balance and some of the important considerations and recommendations that we make to our customers as it relates to finding this balance. And it may differ from application to application. The first thing that we advise our customers is we need to get surgical, and we need to ensure that we're not overprescribing. There's a lot of chatter and a lot of buzz associated with cloud-native application development, app modernization, app transformation. What we need to do is identify which aspects and components of those stories and those sort of paradigms are going to be purposefully instrumented inside of our organization, and yet also understand where there isn't necessarily business value, that we're happy to let some of those paradigms sort of stay on the sidelines, because in many cases we don't want to be modernizing or transforming our applications for transformation's sake only. So we want to identify what we call the MVM, the minimum viable modernization needed to accomplish not only IT goals, but most importantly, customer goals and business goals. The second thing that we'll touch briefly on is eliminating the bottleneck. So many times organizations that we work with identify places where they want to modernize, but perhaps a bit myopically and sometimes with blinders on. What we want to do is take a look at sort of the whole scale process associated with getting a code commit from a developer all the way out until that code is ultimately pushed out into production. And that's not just the developer workflow or the pipelines, the continuous integration pipelines, but it's also the operational aspect of that, as well as the life cycle of that software. So again, we want to think holistically about eliminating the bottleneck. Let's not focus exclusively on the application architecture. And then I think the other thing that's sort of hard to measure, and it's one of those you know it when you see it type of constructs, is get comfortable with the unconventional. Is sort of an architectural posture that we recommend to our customers, especially as we look to find this correct balance. The cloud offers us an opportunity to do some somewhat unconventional things, and we encourage our customers not to shy away from that, based on the fact that this is new. It may feel somewhat disconnected or from sort of the patterns and approaches that we have in the past. But that said, an unconventional approach in many ways can help our customers get to where they want to go faster. Okay, so we're going to use let's dive into this first one in terms of getting surgical and being diligent about not overprescribing. We're going to use a sort of a fictitious example that we use in a lot of our client conversations and workshops called the River East Trading Company. And the River East Trading Company has an API-based application, a markets-based application that's been available and prevalent for the last 12, 13 years. And one of the things that's important is we see this sort of natural evolution inside of the River East Trading Company's sort of software product that we see in a lot of our customers' applications. First and foremost, there's typically older aspects of the application that were once sort of money makers or continue to be money makers. So let's look at the Markets API and the News and Information API. Very, very stable, very, very little functionality, if any, being added, but providing sort of the baseline or the minimum viability of products in the market. So not a ton of change going on there. That said, we also have either newer aspects, such as the Analytics API here, or new ideas in terms of customer ideation and innovation, where we want that sort of dynamic, rapid iteration, get value into customers' hands quite quickly. And so in traditional monolithic application architectures, we have this choice to make. We can iterate as much as we want on the new component, here being Analytics API. But again, inside of that monolithic structure, every single time we make an iterative change, we're going to have to go back out, redeploy the entire application, which in turn means we need to not only institute that development and deploy process, which again may be siloed between development and operations. The other important piece, and we'll talk again about testing, is we need to go out and regression test that entire application code base, based off the fact that we are moving an entire application, an entire sort of monolithic artifact back out into production. And so what we ask our customers to do in a scenario like this is, let's get surgical. Let's not overprescribe. We've got the wonders of networking and microsegmentation to be able to help us. Let's keep the monolith as it is, but let's identify a way to break out the new component or the new API in this particular scenario. And so this is an example of, we really don't need to overprescribe, and we don't need to make every single aspect of this current application a microservice. What we need to do is isolate the places where we need to quickly iterate. We need to put the stitching together so that our monolithic application not only remains intact, but can communicate with some of these newer distributed microservices as well. So again, this is the type of approach not only we would preach, but also one that we would inform our customers that we really don't want to over-rotate here. There's not a ton of value in terms of spinning our wheels and ultimately just modernizing for modernization's sake on the markets of the news and API or news and info API. And again, the idea here is that if we look at sort of the traditional sort of strangler pattern, as we move away from the monolith and move to more sort of distributed microservices, we want to give ourselves comfortable with stopping before we would, ultimately traditionally get to the other end where the monolith has been completely sort of choked off and we have nothing but the individual services left. So again, get comfortable with not necessarily approaching the conventional from a new age standpoint, and don't overprescribe. The other thing that we want to highlight here is eliminating the bottleneck, and I touched on this briefly, but in so many ways, in so many cases, our customers are looking at application modernization as really just sort of a decentralized, sort of distributed architecture of the application code base. So let's take another example here where we've got a traditional sort of e-commerce based application. Let's assume there was a monolith here before, and we've ultimately made it to the point where we have decomposed the application to a set of microservices. We see a lot of customers who will go through the painstaking steps to modernize the application layer and yet leave the data layer intact, which ultimately just moves the bottleneck from the application layer down into the database. So we really want to think about sort of holistic transformation and modernization, primarily to avoid situations like this, where we're just moving the bottleneck around. And it isn't just exclusive to the architectures that we're talking about. If you look at this sort of same architecture, another scenario we see play out is this, modern apps and sort of traditional operations divide. So the application team is modernizing, yet the operations team is staying fairly traditional. And so that, again, from a deployment standpoint, just moves the bottleneck, right? We're moving as fast as we can. We've got a distributed application, but at the same time, the roles, the responsibilities, and some of the sort of operational evolution hasn't taken place yet. And so now we have this, again, sort of traditional, sort of siloed collaboration or lack thereof between these teams, which will ultimately, again, if we're looking at identifying all of the places for us to at least consider, again, we don't want to over-rotate, but consider that impede our progress to move from a code commit and pushing that application out to production. We really want to identify those, and we want to solve for those, or again, put it to the side and say this isn't anything that's going to help us move faster. All right, and then the last aspect of finding the cloud native balance is, again, getting comfortable with the unconventional. One of the things that we see sort of over and over again from an architecture standpoint is this idea of, as part of some sort of dependency, whether it's a backing data store or some sort of third-party service, that there's a very sort of conventional route for me to be able to access that, and I have to use maybe the architectural constructs that are in place today, when in reality, we should take the liberty at any particular point in time to really think about the unconventional. Again, the cloud provides us a really incredible opportunity to be able to do that, and so embracing the unconventional. So here's just a very high-level example of, rather than accessing that data store, which may have sort of a latency cost or penalty to it, or there's very old services that don't necessarily scale in terms of interacting with that data store. Let's potentially move that data out into a cache where we can ultimately, on the backside, control the rehydration and refresh of that data. But then on top of it, we can really build a set of our own sort of scalable APIs. Now, organizations might look at that and say, again, you're kind of challenging architectural norms there. We're storing, or I should say, we've got data in two places. This is sort of the conventional route. Again, that's a case-by-case situation and discussion. That said, organizations would be surprised as to how often we see the unconventional sort of ideas way out, especially as we sort of stair-step our way to true transformation and modernization of these applications over time. So I want to move on to our second key tenet of building a framework for constructing modern applications and modernizing existing applications. And again, this ties directly into this idea of embracing an event-driven approach and kind of using that to stair-step our way to modernization. One of the quotes that I love in this particular arena that really applies is from Jay Kreps, CEO of Confluent. And Jay was one of the instrumental initial contributors and creators of the Kafka technology. And he really kind of challenges our conventional thinking of request and response that we've seen in more traditional application architectures by saying our businesses are a series of events and the reaction to those events. And it really is striking if you think about sort of the traditional, again, request response architecture, as well as some of these other traditional integration architectures, such as batch integrations. So much of that is in stark contrast to the world as we see it today, as it unfolds, which, as Jay's saying here, is really in a series of events. So one of the places that we sort of dig in with customers from an application standpoint is this idea of, let's really look at, first and foremost, how data is flowing through the application. And in many cases, there is in certain scenarios, some reliance and dependency on batch. And so one of the places that we want to include inside of our considerations as to embracing an event-driven approach is, let's look at all the places where we've got sort of batch integrations. Let's sort of liberate and unlock the value of that data. And then ultimately, let's build our sort of distributed application on top of that. And so, again, the why behind this is that you really can't find a construct or an architecture that's in further different from what the digital world expects today than batch integrations, where we expect data to arrive on time, make it available in our hands or in our pockets at any particular point in time when it occurs. Whereas if you look at some of these traditional batch architectures, we have a situation where the sort of transmission and integration of data only happens at various points throughout the day. And in many cases, a majority of the day, that data is in stark disconnect from its source. So liberating of data is ultimately a place that we want to sort of zero in on. And so this is just sort of a visual example of that, where at the top we've got some sort of file-based batch integrations. Those files and transmissions kick off on some sort of scheduled basis, and then only then, at that particular point in time as a snapshot, is the data store then refreshed with the latest information. And as soon as those jobs complete, 5 minutes later, that data is out of date. As opposed to sort of at the bottom, we sort of see this idea of streaming, which is paramount to technologies like Kafka, where data is arriving on time. Appropriate and interested parties are made aware of that through an event and subsequently a subscription to some of the queues or topics where that information is being passed, and then and only then is the application data consumed, and it isn't necessarily waiting on a clock cycle or a period of the day in order to get data that it needs. Again, this is just highlighting, what is data streaming, and it not only helps us in the sort of batch data integration facility. We'll see how it also helps us break down the communication between some of our distributed applications from a microservice standpoint. So we at Ahead take this very sort of regimented process where we will transition some of these integrations from batch to real time. We'll identify how and where the data is flowing through the system, identify where we've got places and bottlenecks associated with delivering data on time. We'll identify and catalog all the appropriate information associated with batch headers, the payloads, the schema, and contracts associated with this data. And then we will look to move that into more of a streaming architecture. Now, aside from the fact that we're keyed in and zeroed in on data movement and the movement away from ideas and constructs such as batch integration, we also use Kafka as sort of an eventing fabric, an event store, and a facilitator for us to be able to communicate specific events that take place across our distributed application architecture. So aside from the fact that we're using it to move data around, we're also using it to communicate in between our microservices layer, using, again, this sort of event-driven approach, or you'll typically hear it referred to as an event-driven architecture, to be able to essentially keep other services notified when key events happen in the system as it originates from an individual microservice. So now kind of transitioning away from sort of this event-driven approach and embracing event-driven architectures, want to circle back to what we had sort of mentioned earlier, which is how do we get ourselves away from this idea of really having to, arduously go back and regression test our applications every single time that we want to build our code and distribute it out to production. And some of these some of the opportunities provided here will be afforded by the applications the application architecture that we're embracing, which is distributed. And so we're going to get away from the idea of having to go and regression test the entire system just based off of the fact that we now have the ability to go out and change things sort of individually. But there's also a higher opportunity here for us to be able to go after, or maybe a secondary opportunity, which is to encapsulate some of the automation as we go through this this process of modernization. So, why do we want to automate testing? That's the question. Manual functional testing, whether it's in a monolith or even if it's in a distributed application, it's very, very expensive. It's time intensive. It's completely manual. The scaling factor there is sort of single pronged in the sense that you just have to add more people to the pool of testers. It can be very error prone because it's dependent on sort of the human aspect of being able to replicate cycles of individual tests. And in some cases, it might provide false positives and results, provided by testers might not actually happen, or might not actually reflect what will happen once that code's deployed into an integrated environment such as production. If we contrast that with automation testing and being able to leverage an automated approach, we transition out of this sort of manual, hard to scale process and sort of hard to predict to a very predictable, scalable model that is incredibly efficient. It provides us at the end of the day a much higher level of not only satisfaction in terms of quality, but it also provides us a great deal of confidence, which allows us to, again, very, very quickly and rapidly test our application code and get it sent off to production, which in turn enables us the confidence again in turn to to institute ideas like continuous deployment, continuous delivery. The other nice thing about automated testing is you get to slowly sort of build up your test bed over time, which creates the safety net for you as you go in and create new value and new code inside of your application. We have this sort of safety net and regression test bed that we have the ability to sort of lean on and give ourselves an understanding as to whether or not any of the new changes that we've instituted or created have broken aspects of the application. So what are the types of automated testing as it relates to how we talk to our customers? There's three types, and this is sort of often referred to as the automated testing pyramid. First, you have unit tests, which are the base sort of level of tests. Then we have integration tests, which build on top of unit tests, and then we have acceptance tests. So unit tests are designed to be incredibly simple. It should provide a one-to-one mapping of an iteration or one isolation of a particular outcome inside of your code. The code coverage ideal. So one of the places we see customers get tripped up is we've got our unit tests. The coverage model is 95%. We want to get it to 100%. That's a very, very slippery slope. There's a level of the amount of effort in many cases that's required to go out and achieve those last few percentage points. So again, another place that we would recommend that organizations not over-rotate in order to achieve an ideal. But again, unit tests are there to be incredibly simple, incredibly straightforward, very, very concise, and very purposeful in terms of the individual tests or use cases that they are there to validate. The next level of testing, as we talked about, is integration tests. And I love this quote from Martin Fowler, who says, "The point of integration tests, as the name suggests, is to test whether many separate developed modules work together as expected." And so we want these tests to essentially validate that the components, once brought together inside of our application, indeed sort of validate that not only do these things work sort of individually on their own, when we bring them together as we would see inside of an actual working application, that we have the ability as well as the confidence to ensure that those particular components work well together and don't encounter any errors. These tests should be incredibly fast as well. So obviously with a couple more components being brought together, not going to be as fast as unit tests, but any sort of dependencies or third-party components we typically want to be able to mock, and a lot of modern unit testing frameworks have the ability to mock. And again, the idea is that we want to be able to integrate, we want to be able to test specific scenarios. We want to do that without having to sort of lean on other teams, or we want to be able to mock those scenarios out so that we can ensure all bases are covered in terms of testing. And then lastly, we have sort of end-to-end testing, which is what you would expect. These tests require sort of live versions of all services, any dependencies that we have. End-to-end services should also go through all of the individual code paths inside of the application, front end, back end, database as well. This is typically the last set of tests that are run inside of some sort of CD pipeline, and ultimately these are going to be the longest running tests inside of again. Not only this portfolio of automated tests, but inside the pipeline as well. Now, automated tests are great, but one quote that I heard about 5 or 6 years ago is that they're the most expendable and quickest sort of ejectable aspect of your code base. Whether they're ejected, whether they're abandoned, if tests are too hard to understand, if tests are constantly breaking, tests are just going to become disposable. And the moment that we turn our back on our tests, we lose almost immediately the ability to, one, have that confidence as well as that safety net that the changes that we're instituting are not breaking the application once it'll be deployed to production. One of the questions that we get is, what's the adequate time investment associated with automated tests? Tests, or I should say, it's a similar delicate balance. If we're spending too much time with tests, that's a sign that we're not writing tests the right way. Ideally, we're spending about 10 to 20% of our time on tests. We want it to be efficient. We want it to be very, very purpose-driven. That said, this is not production code, and we don't want to spend a considerable amount of our development team's time writing tests. So when we walk into organizations, we typically see one, either abandoned tests, or two, tests that are too complicated, spend or require too much time to be able to be spent on them. And so in many cases, there's a simplification exercise that we walk our customers through. Now, tests should change the way in which we work. We should always be thinking about a particular use case as a developer, and so we recommend a test-driven approach. Retrofitting tests on an existing application is impossible, and I would also argue that it is a waste of investment. That said, in many of these monolithic applications that we're modernizing, there's this idea of, as Sir Dennis Healy would say, the idea of stopping the digging process and to pivot more towards this approach. So as we go through the process of cracking open these applications, decomposing them, this is really the first opportunity to make that pivot and start building some of these automation and regression test beds up. A sign that your tests aren't working for you. It's another sort of insightful piece of information that I heard a couple of years ago, and I think it's a great litmus test, which is if you are a developer or your developers are spending too much time inside of their integrated development environments stepping through code, and yet you're making a significant amount of investment in tests, your tests are essentially not working for you. If there is any sort of issue, especially one that comes back from production or one that's found from a QA tester, in many cases, you should be able to pinpoint that use case and that test. And if there's something wrong with the test or there's something wrong with the code as it relates to how it was built per the requirements, that should be an easy fix. And then in the future, again, if we have some sort of change that we institute that breaks that area of functionality, our test should be able to tell us that immediately. And then lastly, just a kind of a highlighted contrast of application code versus test code. Again, we talked about the fact that there's a lot of value from our development teams writing application code. In many cases, it's going to be complex, but it's going to be elegant, or we want it to be elegant. And the idea there is that, again, this is where the rubber meets the road in terms of, highlighting and identifying how value is constructed through software. So there's a certain level of elegance there, from conditional statements to component-based architecture. Very much an art and a science, whereas test code should be much more sort of science-driven. Tests should be extremely simple. Code should run linearly. Each test should handle one path of a particular use case and sort of move on. So we find that sort of that contrast very important. So just in review, we've identified our framework for building modern applications, as well as modernizing existing applications, finding that cloud native balance and the considerations there, embracing an event-driven approach, whether it's thinking about some of the traditional integrations, batch integrations around data, or it's around how do I get these distributed components inside of new cloud-native application architectures to communicate together. Kafka and sort of an event-driven approach is key there. And then again, as we sort of pivot to new architectures, how do we move away from this process where every time we want to instrument a change and deploy it out to production, we've got to kick off a list of manual tests. let's look to not only test in a new way, but let's build up a regression test bed that can give us the confidence that we need in order to more rapidly deploy in the future. So hopefully you've enjoyed this talk. Oh, sorry about that. Let's jump in at this particular point and answer some questions. So one of the questions, the first questions that we got was around the cloud native application development process as it relates to maybe some of the considerations outside of application architecture, right? So things like monitoring, observability, security. We touched on it briefly in Dave's talk and a little bit more at the tail end of some of the questions that he was getting. But one of the things that's interesting is we are moving away from sort of monolithic applications, as we talked about, moving into a distributed architecture. And in many cases, there's a whole new set of tooling, whether it be native tools provided by the public cloud providers, whether it be or leaders in each particular space or domain. So whether it's observability, whether it's monitoring, whether it's logging, significant considerations need to be made there. There's also opportunities to double up on some of the technologies that you might already have in-house. So a good example of that would be Elasticsearch. Many organizations are using Elasticsearch not only for some of their front-end applications, their digital applications, but they're also using the Elk stack from an observability standpoint. So lots of considerations as it relates to cloud native, especially based off the fact that we're moving moving more towards distributed applications, if that makes sense. Next question that came in, Mike, you mentioned testing. Should we be testing back-end API services, front-end applications, or potentially both? And if so, what framework would you recommend? So the answer to that question is absolutely both. We're moving to a world, as we saw in that third section there, where testing and giving ourselves the confidence has really just become paramount in us being able to move as fast as we want to from a custom software development standpoint. So the traditional application stacks that we see from a back-end API and from a back-end system standpoint would be Java and .NET. So the prominent testing frameworks there. For Java, it's JUnit. For .NET, it's either NUnit or XUnit. In terms of front-end applications, JavaScript-based applications, especially in web applications, that has a testing sort of community and set of products and frameworks that are growing and evolving there too. The two that we see most often are Karma and Jasmine. So absolutely be testing all across your application. That's what enables us the ability to do things like the end-to-end tests, which will run at the end of our pipeline. Another question here, our organization is heavily dependent on batch integrations, which obviously is not a surprise for me to hear that, but our customers demand a more real-time look at their data. How would you suggest that they start moving towards, how would you suggest that we start moving away from batch and embracing streaming in real time? And so I think it's a great question. I think one of the places that we see organizations typically struggle, and a great place to sort of institute a technology like streaming or Kafka right out of the box is organizations have a really hard time moving critical data across their organization. So we see a lot of organizations that have traditional batch and ETL data pipelines where data needs to take multiple hops across different areas of the sort of enterprise IT portfolio, across different tools, different systems, different databases, in order to get from source to target. And that's one of the places where Kafka really just shines out of the box, is that it has the ability to essentially tap into that sort of change log and sort of event log model that's very common in relational database systems, and essentially take that data as it comes in, as it's written to the log, and then ship that to one or more sort of sync databases or target databases. And if you contrast that with the multi-hop process that we see, where again numerous tools, numerous applications are involved, the simplicity and the elegance of that solution, as well as, back to this person's question, having the ability to provide real-time data into your customers' hands with the digital interactions or digital assets that they're interacting with that belong to your company is just a monumental change, and it really signifies the difference between the way that we used to do things versus sort of the new paradigms and new technologies like Kafka, if that makes sense. Just going through the rest of the questions here. It looks like we have time for one more question. One just came in here. Our company is looking to get out of the business, as you stated, Mike, of wrestling traditional enterprise infrastructure. We're thinking about embracing containers. How would you suggest an organization like ours select the right platform for us? I think that's a great question. It's one that we get all the time, so much so that we're actually bringing some of these key learnings to a session later today called Choosing the Right Container Orchestration Platform. Myself and my peer, Tim Curlis, on the DevOps side from Ahead, will be talking about, essentially when we're asked this question from our customers, what's the process and the set of recommendations that we ask, or that we sort of ask our customers up front, and then ultimately sort of walk them through the journey of everything from sort of procuring the right solution to standing it up and getting it installed, and then most importantly, to deliver a set of business and IT outcomes on top of that. So whether it's moving away from the traditional wrestling of infrastructure and sort of the cost savings there, whether it's building these cloud native or modernizing existing monolithic applications to move them onto that platform, that's the end goal here, to be able to support the business and to be able to support downstream customers in a much more easy and streamlined way. One last question that just came in. For third-party applications that have been customized a great deal and are using a lot of input and output of data, what framework would be best to move to the cloud? Are you able to identify which of these frameworks that we should be able to use? So I think it's it's difficult to say. It's without understanding maybe a bit more about the specific application that you're talking about. One of the things that we see is a lot of sort of COTS and third-party applications are moving to the cloud. They're being moved to, I would say, an even more sort of vanilla SaaS offering. And so custom applications, custom product companies, custom software product companies are really moving away from the model of being able to allow customers to extend their solutions, primarily due to the fact that it's just been so problematic in terms of providing support. So one potential option is to sort of resurvey the landscape, identify what tools are out there, and potentially there's a SaaS offering. In terms of the third-party application, it really depends. It depends on the level of support that's provided by the third party on its own, in terms of what will they allow to be sort of modified or extended or modernized. It depends on the application stack and the tooling. So if you've got a 20-year-old application that's running, let's say COBOL, maybe it's a mainframe application or a Kix application, we're going to be, or you're going to be, subject to what advances are available in that technology in order to modernize. And so if you look at a lot of older languages, there isn't the ability to essentially snap in a lot of these sort of cloud native frameworks out of the gate. So it's a it's a delicate balance there, and unfortunately it really depends on the third party software that you're working with first and foremost, and what they're going to be able to support, and then secondarily what technology that the extension or modernization can take place in. And if it's in a dated technology, you're going to have to rewrite a lot of that boilerplate code because it's just not there in a lot of older frameworks, if that makes sense. Okay, I think that is it for the list of questions that I've seen that have come in. I really appreciate having the opportunity to be here to, again, follow after Dave's wonderful talk this morning. Looking forward to the rest of the day. Hopefully you'll stay on with us. I've got a lot of great sessions, as I mentioned earlier. Tom, looking forward to throwing it over to you and moving to the next session. Thank you so much. Appreciate it.
All right. Thank you, Mike. And thank you, Dave, as well. Great stuff. So in the spirit of giving you all a bit of breathing room in your calendar and letting you squeeze in some of your day job, we're going to take a short break now. We'll actually reconvene at 2 p.m. Eastern to hear from AHEAD's Tim Curlis, another one of our chief cloud architects, on Mission 2, providing what we call environments on demand to deliver better software faster. Then Tim's going to be joined by Mike Coleno, who you just heard from, for Mission 3, and that's choosing the right container orchestration platform. So we'll see you back then at 2 p.m. Eastern.